Hello class, welcome to Pre-Algebra Lesson 2.7, which is all about learning more properties for integer exponents. By the end of this lesson, you should be able to write a number with a negative or zero exponent in a different way. So first, let's talk about what does a zero exponent do? Oftentimes in math class, when we see zero, we often think 0, okay? Because if I were to ask hey, what's 3 times 0? Oops, 3 times 0, you would often reply very quickly 0. Or if you're rushing on just a little too much, you might say 3, and then when I look at you, you might be like, oh, wait, 0. So be careful that you're not rushing and jumping to a conclusion that's not going to be true. Okay, so here you can see that we are told to evaluate 3 to the 0 power. Okay, so we're trying to figure out what does 3 to the 0 power equal. So you can see down below I have the screen split into two. Okay, so I'm going to show you two different ways to give you some visuals to figure out what the 0 power does. And starting with this table over on the left, you can see I wrote out a bunch of different powers of 3, a bunch of different powers of 3. So I said, hey, 3 to the 4th power, that's going to be 81, 3 to the 3rd is 27, 3 to the 2nd is 9, 3 to the 1st is 3, 3 to the 0 is, and I have a blank. So what I'm going to do is I'm going to look at this column and I'm going to see how are these numbers changing. So to go from 81 down to 27, I am losing a 3, right? I am dividing by 3. And then going from 27 to 9, again, I'm dividing by 3. Going from 9 to 3, I am dividing by 3. So since math is all about all of these patterns, we can assume that my next step is going to be to divide by 3. Excuse me. So what is 3 divided by 3? It is 1. Okay, so you'll see 3 to the 0 power equals 1. And if you type that into your calculator, so again, yesterday we quickly talked about how to type it into the calculator. So you would do 3, you would use your little caret key, you would hit 0, and then you would hit the equals. And it would give you the number 1. And that's absolutely perfect. Something for you to know is any number raised to the 0 power is going to be 1. And as you move forward in math, any variable or letter raised to the 0 power also turns into the number 1. Okay? So that table is meant to help you visualize why anything to the 0 power would equal 1. Let's take a look at what if I were to write it out. So just like yesterday, division, another way to do that is a big fraction, right? So if I said 3 times 3 times 3, that's my numerator, and then the bottom of my fraction is again 3 times 3 times 3. Okay, and if I were to do that, if you actually want to do that, so 3 times 3 is 9 times 3 is 27 over 27. What is 27 divided by 27? If we simplify that, it's the number 1. So you can see that 3 to the 3rd divided by 3 to the 3rd, that is the same as we talked about, 3 to the 3 minus 3, right? Because that's what division does for the exponents. We end up subtracting the exponents. So that's going to be 3 to the 0 power. And 3 to the 0 power, as you can see from up here, equals 1. Okay, so anything to the 0 power equals 1. So now I want you to take a moment and I want you to evaluate this expression. Now we have a negative 7 raised to the 0 power. Go ahead and type in what you think your answer is. Good luck. Alright, for this problem, hopefully you said negative 7 to the 0 power is going to be 1. Sometimes I'll see students think I'm trying to get a little tricky and that it's going to be a negative 1. It's not. It's just going to be a positive 1. And the reason I know it's going to be a positive 1 is because that negative is inside those parentheses and the 0 exponent is outside of the parentheses. So that means that 0 applies to everything, including that negative. Now, if we had a slightly different problem where I said negative and then in parentheses I had 7 raised to the 0 power, this would be an example of -1. And the reason for that is when you have a negative outside of parentheses and there's no number, there's like this little itty invisible 1. Okay, so it's almost like saying I have the number -1. So I have a -1, and then that 7 to the 0 power becomes a +1, and -1 times a +1 is a -1. Okay, so when you have a number outside of your parentheses, it does not get converted to a 1. Okay, so let's say for a moment I had -2, and then in here I had 10 to the 0 power. This would turn into -2 times, and then 10 to the 0 power is 1, so my answer would be -2. Okay, so just be really careful that you're paying attention to the location of numbers before you multiply. All right, the second example, we are talking about something called the negative exponent property. So what I like to compare this to is if you were to write the fraction, let's go with like 7/21. If you were to write that, and I had said, hey, I wanted you to write your answer in simplest form, you would not get full credit for this problem because it can be reduced, right? 7/21, an even simpler way of writing that is 1/3. Okay, so that idea is what we are going to be working with in this example. So 4 to the 3rd divided by 4 to the 5th. So if we were to write that out, just like I had said earlier in this video, remember division means you subtract your exponents. So I would have 4 to the 3 minus 5 is a -2. And you'll notice we have a negative exponent and we haven't had that before. So let's talk about what does that actually look like and what do we do when that happens. So let's draw a little picture. So on the top of this fraction is 4 to the 3rd, right? It's the first thing listed, so it goes on top of my fraction. And remember, division is just another way of writing a fraction. And then I have 5 4s being multiplied together on the bottom. And if I were to go through and simplify this, right, if you're multiplying everything and you have the same number top and bottom, they cancel out, right? But do I just leave the top of the fraction as blank? No. It's kind of like how over on this problem, instead of just saying that the 7 went away because they're both divisible by 7, I put that 1 there. You're going to do the same thing. Those are all really just turning into 1s, like if you think about it. So 1 times 1 times 1 in each of those spots. But we never have to write times 1, so that's why we usually don't. And then you can see I'm still left with, I have a 4 here and I have a 4 here. So you can see I have 2 4s on the bottom. And now that I have those written on the bottom like that, I see that my 2 is now positive, and that's an answer that I like because in order to be fully simplified, I need positive exponents. So if you don't want to draw out a picture, what can you do? You can subtract your exponents. So like I started this problem, 4 raised to the 3 minus 5, that's 4 to the -2. What you do is you make it a fraction and you move it to the, in this case, bottom. Okay, so my answer would be 1/4 to the 2nd power. If I asked you, instead of leaving it as a simplified expression, if I asked you to evaluate, what you would do is you would say 1 over, and then 4 to the second power is 16. Okay, so you want to pay attention to what the directions say and make sure that you are following those. All right, I'm going to do one more example on this page. Let's say for one moment, actually no, because it's going to be the next example. All right, you can go ahead and try question number 2. I want you to simplify the expression, so that means you need to rewrite it without a negative exponent. Good luck. Okay, for this problem, hopefully you said with that negative second power, we have to move it to the bottom of, we have to turn it into a fraction and then move it to the bottom in order to get rid of that negative. So simplifying the expression, your answer should be 1 over 8 to the second. If I had asked you to evaluate, which I did not, but just good practice, 8 to the second is 64. So my answer would be 1 over 64. All right, now let's talk through this right here. Write the expression using only positive exponents. All right, so this looks a little weird, right? I have a 1 over 7 to the negative third. I'm going to change that 1. I'm going to say that's really a 7 to the 0 power. Okay, right? Because we said anything to the 0 power equals 1. And then on the bottom, I'm going to have 7 raised to the negative third. And we talked yesterday, when you're dividing, you really are subtracting your exponents together. So that becomes 7 raised to the 0 minus a negative 3. 0 minus a negative, that turns to plus, so 0 plus 3 is just 3. So my final answer ends up being just 7 to the third power. Okay, the fraction's gone because what's happening is I'm taking that and I'm moving it to the top in order to make it a positive exponent. All right, I'm going to do just a couple more examples here. Let's say for a moment that maybe I gave you something that looks like this, where I have 2 to the negative fourth on the top, and then on the bottom, what if I had something like this, 3 to the negative second? So my bases don't match, I can't combine them, but I want to simplify this. What you do is anything with a negative exponent, you move to the opposite part of the fraction. So if it was on the top, it goes to the bottom. If it was on the bottom, it goes to the top. So 2 raised to the negative 4 is on the top of my fraction. So to simplify it, I would move it to the bottom and get rid of that negative. So 2 to the negative fourth on the top is the same as 2 to the positive fourth on the bottom. Okay? Then I need to move 3 raised to the negative second power on the bottom would become 3 raised to the positive second power on the top. And so rewriting using only positive exponents would look like this. If I asked you to evaluate now, you would say 3 to the second, that's 3 times 3, which is 9, and then 2 to the fourth power, that is 16. So this is what you would write if I asked you to evaluate. All right, now let's try just one more. I'm going to make it look really similar, but ever so slightly different. Okay, so I want you to simplify this expression. So you can see I no longer have numbers for my bases. They're now letters. They're my variables. The same rules apply. So I have the variable x raised to the negative fourth power. If I wanted to rewrite it with positive exponents, I'm going to do the same thing that I did right above. I'm going to move it to the bottom of my fraction. So do you see how it's connected? Like 2 to the negative fourth, in order to make it positive, I moved it to the bottom. Same with the x. That means I'm going to do the same thing with my y. Instead of having y to the negative second power on the bottom, I'm going to do y to the positive second power on the top. And that will be my simplified expression using positive exponents. All right, last problem for you to try on your own. I want you to rewrite the expression using only positive exponents. Good luck. For this problem, hopefully you ended up with 5 raised to the 6th power. Okay, if you got rid of the fraction, great. If you said 5 to the 6th power over 1, that's also okay. We just typically don't write fractions over 1. Not that it's wrong, it's just more work, and we're all about keeping our work shorter but cleaner. Alright, so then here you will find just a brief key concept that highlights these two properties. These are another couple of properties you want to make sure that you know. So if you have started making flashcards for the properties from yesterday, here are the other two that you want to make sure that you make note cards for, or flashcards. If you have questions about this or anything else from the video, please do not hesitate to ask. I am more than happy to help you. Have a great day.